我这是可以了。
Yeah, now it's recording. Hi everyone. So we have two guests here, and I'm the speaker, Hui Yu. So today I'm going to talk about the maximum post-territorial probability estimation. It is another kind of estimation. So last time the professor talked about the maximum likelihood estimation. The MAP estimation is very similar to it. So before we go into the real estimation, this is the background that we need to know. The first is the pirate density, which is something we learned in the probability class. And also this is the probability to have X when we know that Y is there. It's also something we learned from the probability class. So the MAP estimation is just minimize these functions over X. So here Y is the observed value and X is something we try to minimize. And the difference between the MAP and the ML estimation is the second term, which is the PXX. So the relationship between the ML estimation and the MAP is that if the ML estimation has a concave log likelihood function, and if we can add a pirate density log concave X to the result, then we can form a convex MAP estimation problem. Now we are going to talk about the linear measurement with the IID noise. IID stands for the independent and identical distribution. So here is the equation that we are going to use. It's the same with the ML estimation. So here we have the VI, which has the density PV, and we have X, which the density is PX. And also we need to know the joint density here formed by these functions. So this time the MAP estimation is changed into minimize these things. And here, if we know the PX and the PV are log concave, then the problem is convex. And also the difference between the MAP estimation and the ML estimation in the linear measurement condition is that we have an extra log PXX. So here is the example to have the IID noise. So if we have a VI, which is uniform on the negative A to A alpha, then and also if we know the Gauss distribution X with the mean X and the converse, here is something we learned in the probability class. Then we can use the QP to solve the MAP estimation by having this optimization problem. Yeah. So the last topic is about MAP with the perfect linear measurement. So this time there's no noise. And here the function, the subject is just AX equals to Y. And we also have X, which the density is PX, just like the one with linear measurement with noise. So here the MAP estimation is just maximum the log PXX subject to AX equals to Y. And also here PX, if PX is log concave, then the whole estimation is convex. And the last thing is the least penalty problem, which we maximize the sum of the log stuff. And also the subject is just AX equals to Y. And here the penalty function is this one. And that's it. Yeah, so thank you for listening. It's just for the Thanksgiving surprise. Thank you.
Thank you.
Thank you. All right.